So next in our programme this morning is Mark Siddle from Jisc, and he's going to come and talk to us about how we can use Splunk to our advantage. Mark, if you could come
on. Right, good morning everyone. Hopefully you can all hear me. So this is my first time at speaking at you, CSIRT, so thank you for having me. My name is Mark Siddle. I work in the Security Operations Center at Jisc, and today I'm going to talk to you about how we've been using Splunk, and perhaps some takeaways for you could be about the sorts of use cases you could use and how you could approach implementing a seamless-like solution. So just a bit about me. I've actually worked in the academic sector for about 10 years. I initially started working at the business school at Oxford University, doing kind of desktop and infrastructure support. I then spent about 18 months doing network operations at the Central Computing Services for the University of Oxford. And then I've been working at Jisc doing security for about 6 years now. So I started in 2013 in Janet's CSIRT, and that was when it was actually Janet, not Jisc. And the way that security was kind of split up then was that we had our CSIRT team, who you probably dealt with quite a bit, who looked more after the sort of Janet network side of things. We had our strategic technologies department, who did more of kind of research into security and kind of service design, that sort of thing. And then kind of once we'd kind of become a much larger Jisc group, we then had an information security department who looked after the kind of internal security side of things. So hopefully, all right, we're not a university, but we still have various different kind of technical departments, different kind of silos, and hopefully somewhat you can relate to that. So fast forward a bit to January 2017, post all of the kind of the Jisc merger, we formed a cybersecurity division that comprised of our CSIRT team, our DDoS mitigation team, who looks after our Arbor Networks equipment. We had an infrastructure team who do more kind of systems engineering and kind of VMware, that sort of stuff. We had DNS team who looks after the kind of primary name servers and a kind of small resolver service that we provided. And then we also created a professional services team who were doing kind of penetration testing. Some of you might have used their services already. And now, where we currently stand, we've kind of jigged things around a bit. We've had a bit of a restructure, and now we've kind of got a security operations center, which comprises of a CSIRT again, DDoS mitigation, and more recently a threat analysis team, who are looking at kind of threat intel and looking at phishing campaigns and different malware infrastructure and things like that. We have our engineering team, which is comprised of the previous infrastructure team and the DNS team. We have professional services, which is kind of branching out more into compliance, so they're looking at things like Cyber Essentials, and things like that. And then a kind of service delivery team who deals more with kind of support of those services, management of those services, and kind of service delivery, so things like service design and architecture. So we have the Security Operations Center, and we need to kind of start looking at what, we need sort of visibility into our systems. So we have some key objectives around kind of improving our security posture at our division, because ultimately, if we are a cybersecurity division, we should hopefully know how to do security pretty well. We want to start making use of kind of available threat intel, start building our own threat intelligence, which is why we've kind of built a threat analysis function. We also want to reduce the amount of interfaces we need to monitor. You guys can probably relate in the sense that, you know, we've got monitoring interfaces, like web interfaces, we've got kind of DDoS mitigation systems, all these different kind of web front ends that we need to monitor, and switching between all of them can be quite time consuming. We want to provide more reporting to management about how our services are doing, the sorts of trends and themes that we're seeing across the network. And we also want to set an example to the sector around how people could be doing security, ways in which they could improve it. So we decided that we needed some kind of log aggregation, or like seems-like solution. Previously, we were kind of using Greylog, but it wasn't necessarily really being used in any kind of proactive way. There was no real dashboards, there was no real alerting or anything like that. It was literally just a repository of logs. So we drew up some initial requirements, and so that started off with, we need a single pane of glass for detecting and investigating any security incidents we see. We wanted a solution that we could get value out of quickly, that our analysts could use. It didn't really take a huge amount of training to get hold of. We needed it to be easy to administer. We didn't want to have engineers with years and years of experience of kind of different database systems or different NoSQL database type solutions. We also needed some scale for a managed service. So one of the things that we frequently get asked for more and more is managed services, and logs aggregation and SIEMs were the sorts of things we're being asked for. So we needed to somewhat escalate that a bit. And again, it's about taking what we know and the knowledge we have and sharing that with the sector, so hopefully you can start to build better detections yourselves and learn a bit from kind of what we know. So it really came down to, for us, the kind of build it or buy it sort of decisions. And these are probably decisions you have yourselves as well. Jisc, or even Janet, historically has been one of those organizations that always kind of really built things themselves from the ground up. And that's slightly changing in certain areas, really where either we really rely on it for our services or whether it's services that we're providing to members themselves. So for us, the reason why the kind of build it solution didn't work for us was because we're low on resources. We don't have teams to manage huge sets of infrastructure. And we didn't want to be in one of those situations where only one person knows about a particular system. It's all well and good having really, really clever people. And if they can program all this stuff, it's really good. But if that person leaves or gets hit by a bus or whatever, then who takes over that management? If it's not properly documented, how do we deal with that? And so we need something that we knew that we could support regardless of kind of employee turnover. So we chose Splunk in the end after doing various different pieces of research into commercial solutions. Some of the solutions that we saw were either they weren't flexible enough, they were perhaps too security focused, where we wanted something that could do security, it could do operations, and we ended up with Splunk. So for us, we need to ingest potentially terabytes of data a day, potentially when we're looking at providing more managed services. We need it to be multi-tenanted to make sure that any data that we have in Splunk was kept separate, particularly, again, when it comes to managed services. We don't want one organization's data being merged with another. We wanted training paths available so that our system engineers, our analysts could get to grips with it really quickly. One of the things that we found, particularly when we were looking at the sorts of open source solutions for this, was that there was rarely any kind of decent training, particularly on the kind of security analyst side. It was, we were looking at Elastic as an example, and they have training for kind of building Elastic systems and kind of system engineering, but not necessarily how do you get value out of it as a security analyst. So we wanted some decent training paths so that we could not just put our analysts through it, but it meant that we were able to get value out of the product much quicker. Splunk has a number of add-ons, both premium and free through Splunk base. And that meant that there was already kind of built-in use cases that we could use. A lot of the add-ons do all of the kind of data ingest for you. It saves you a lot of time, and that was quite a key win for us. One of my kind of bugbears, particularly around open source software, and don't get me wrong, it has its place, but very much around documentation. Splunk's documentation is really, really good, both as a user, as an engineer, as an architect. It covers the whole lot, and it covers, goes back quite a few versions as well. So if you haven't quite updated the latest version, you know that you're still going to get some kind of support there. And ultimately, there's an existing knowledge base within our sector. We know that there's kind of around 20 organizations that are already using Splunk. So we knew that there was an existing knowledge base that we could learn from and that we could add to. So you may be kind of going through a similar journey yourself. You might be looking at different either commercial solutions, or you might be using open source. It depends on what works for you. But all of these things can be quite overwhelming, and you might not be thinking, you might not be sure quite where to start. So this is kind of what we felt is a good way of looking at it. So come up with your use cases to start with. What do you want to get out of your data? What questions do you want these systems to answer for you? And then once you have those use cases, you can start to put together the sorts of data sources that you need to fulfill those use cases, whether that's things relating to authentication, it could be related to your firewall data. Once you have those use cases, you can start to build on those sorts of data sources. And then once you start ingesting your data, you can start creating content, whether that's your dashboards, reports, alerts. And then once you've kind of created that, it's kind of observing what's happening within your environments, and trying to figure out where there's too many false positives, where there's only room for improvement, can you tune things? And then once you've improved them, then it's a case of, okay, well, I've done this use case, where do I go to next? So for us, the best approach is, right, okay, we've got all these use cases we want, but how do we prioritize them? And again, it really comes down to, what do you want to know from your data? Is there any quick wins that you want? Have you got compliance requirements, for example? Is there kind of data that you know that's easily available? You collecting it via syslog already, which would make things a lot easier. Is there specific detection use cases that you want to find? Do you want to detect ransomware in your environment? Do you want to detect the latest piece of malware in your environment? But ultimately, starting with the basics is always a good idea. Kind of don't run before you can walk sort of situation. So again, this might not work for you, but this is the sorts of approach that we took. So we use Cyber Essentials as a bit of a guide, and hopefully that will somewhat seem familiar, particularly after the last presentation. So the initial one was focusing on access control. We want to know, who's logging into our systems, where are they logging in from? Is one particular system trying to log into multiple systems using different usernames, the same username, is that sort of thing. And the graph on the right there shows which source hosts are trying to authenticate using multiple different usernames. So you can see that around about between 2 and 4 a.m., we had 2 spikes of activity where one system was trying up to 200 different usernames at once. Luckily for us, that was just our vulnerability scanning schedule. That wasn't anything too malicious, but it's the sort of things that you can get, the sorts of insights that you can get into your environment. The next is our firewall data. So we wanted to know, is there any systems that are infected or compromised with our environment? Are they scanning internally? Are they scanning the internet? Is any system perhaps sending more traffic than normal? Are they sending traffic over a large duration of time that might suggest that there's some kind of data exfiltration going on? Are we seeing traffic to any known malicious infrastructure, sort of malware campaigns? And then we also wanted to take all of our antivirus, anti-malware, we want to call it, data and stick that into Splunk as well, so that we can actually have a centralized view of what's going on. So not only do we get the alerts into our system, but then we can use the data that's already in Splunk to either enrich that or to do further investigation work. And then lastly, we wanted an overview of the sorts of vulnerabilities we have in our environment. So we were taking in things from our vulnerability scanners. And again, it's providing those sorts of dashboards that give you an overview of your state of play, if you will, from a vulnerability point of view. So once you have your use cases, you can start to think about data sources. So again, we were looking at things like, okay, well, I want to know who's logging into what and from where. So we're looking at things like Active Directory logs. We have quite a large Red Hat estate, so we were collecting all of our Linux authentication logs, VPN logs, particularly if we want to determine is someone logging in to our VPN from the UK, but also logging in from another country, for example, within close proximity of time. With our firewall data, we knew, okay, well, to be able to find scanning traffic, to be able to find kind of large flows of data, we're going to need to know when a session was created. We're going to have to know when a session was closed for the duration of data. And then it's also quite helpful sometimes to get the session denied data. So you might not be necessarily that interested in knowing that every IP address on the internet is scanning you, for example. but knowing what's being denied outbound from your network is quite handy. So yeah, again, event data from our malware vendor. So we use CrowdStrike for our antivirus, and that allows, we can connect to their API and pull in all the data that we need from them. And we take scan results from our Greenbone vulnerability scanner, and that provides us and management with a really good overview of how we're doing vulnerability-wise. So once you've kind of got those sort of basic use cases down, you can start to look at perhaps more advanced things. So we find that taking information or what we know from previous incidents, so if you had a security incident in your network or in your organization, is there data that you can take from that knowledge? You know, is there something that, is there a way that they got into the network that you didn't have visibility of before that you can now start to look for in your environment using Splunk or another tool? Network traffic outliers is another one. Like I said, it's not just a case of, okay, well, this traffic is sending large amounts of traffic. It could be, okay, well, does this host usually send this amount of traffic? Does this host usually try to log into these different systems? We're then looking at sort of privileged account activity. So I mentioned before that we use a lot of Red Hat systems. So what we do is we enable the audit framework logging, and that allows us to see not just, okay, this user logged into this Linux host, but we can say, okay, well, they were logged in, they became root, and then they did these activities. And that's the sort of thing that we can start to piece together using Splunk. Lateral movement is another one that we see quite a lot, particularly with kind of more modern pieces of malware. If you take things like WannaCry and stuff, it's all about moving laterally within the network. And you can pick that up with, you know, firewall data, but you can also pick that up with your authentication data. So what you might see as a bit of a common theme here is that the data that you're ingesting, even for your basic use cases, can be used for a lot more advanced use cases as well. It's not a case of, okay, well, I've got this data in and I need to go and find all these other systems. A lot of the time, the data you have can be used for multiple purposes. Device inventory, so that could be taking information from something like SCCM. Perhaps you have an MDM solution that gives you things like patch status, what sort of software is installed in your environment. And then threat lists, so taking in things like threat feeds, whether you use a commercial tool or whether you use something like MISP, for example. So we use MISP as an information sharing platform, and we can take data in from there and we can look for kind of indicators of compromise within our network. If you are using Splunk, I would suggest that you look at Security Essentials. It's a free app from the Splunk base. It doesn't implement anything for you, but it's really good at giving you ideas on what you could be doing with your data. It actually, you can pick a particular use case from their kind of library, if you will, and then it'll actually scan your environment and within Splunk and see whether you have the data available, or if you don't, what sort of data sources you need. So I kind of posted this little circle of use cases and how to approach things. But one of the things that I find, particularly from creating content within our platform and creating alerts and creating correlation searches, is how do I know it's working? How do I know that the thresholds that we're setting are going to pick things up? How do we know that perhaps we're setting things a bit too restrictively, for example? So one of the things that we're now working on is working with our pen test team to start testing those correlation rules, testing those alerts, testing those dashboards, and making sure that actually what we think we should be seeing, we are actually seeing. And for yourselves, that could be that you have security staff internally that you could use to start testing those things, having those sorts of red-blue team sorts of challenges. Or if you don't, perhaps it's the sort of thing that you might want to think about when you're next procuring a pen test engagement, for example. You might want to get them to check over your critical systems, but if you've got the time and the funding available, then it might be worth testing that your security controls are actually doing what you think they are. So for us, it's about improving our security posture, and that includes things like system visibility. It includes things like policy violations. So this little picture on the right here that looks, I suppose, a bit like it's been redacted by a 5-year-old. But PowerPoint is what it is. But this particular graphic shows where, so we have a policy where our system administrators must have two-factor authentication. And so what this shows is any user that doesn't have two-factor enabled on their account and how many admin groups that they're actually a part of. And so from that, we can take that information and then make sure that those users are complying with our policies. You might want to look at whether people are bypassing security controls. So with our, we take DNS query logs from our DNS resolver service, for example. We use RPZ. So it's very important from us, from protecting our user base, if you will, that we can protect our users from phishing, malware. And so if people are bypassing that control, we need to know about it. So we can look to see whether people are using, Google resolvers or Cloudflare or whatever. And the sort of search at the left-hand corner there shows, any sources that are doing so. And then again, we can go and fix those. So it's not just necessarily about picking up the latest threats in your environment. It's about understanding your environment from a security point of view and whether there's anything that needs improving. So as you start to improve your posture, you're starting to reduce risk as well. So you're identifying gaps in your visibility. So it's quite easy to kind of just think that you know about the systems that you own. But hopefully going through this process of looking at authentication logs, it should show you perhaps systems that you didn't know about. And you might end up having to answer questions around, okay, well, this data is coming into Splunk, but I don't know who owns that system. And that's the sort of things that you can look at. Discovery of misconfiguration. So this bottom right graphic here shows where some systems in our environment were actually sending all of their logging traffic to a system that no longer exists. So it's not necessarily directly a security problem, but it could be if any of those systems got compromised. And having all these different web interfaces for your systems, I believe that if you've got 10 different systems that you need to monitor, there's a good chance that you might actually miss something because you're not looking in the right places, whereas having everything in one place hopefully should mean that you don't miss things. And if you've got more data, if you've got all the data in one place, that should hopefully make things a lot easier for you in terms of responding to incidents, investing in incidents, and getting to the root cause of why something happened. And we focus very much on actionable alerts, so we want to know the alerts that we have configured, we want to know that we can do something with them. If we can't do something with them, then there's little use to it, and it means that our analysts are spending more time on things that we have no real control over. So just a few use cases that we've pushed out around our organization. So we're working with our DevOps teams for things like application visibility and troubleshooting, our network resolver service, so we're taking in RPZ logs, for example. We're working with our cloud teams around how do we get data in from things like CloudWatch and CloudTrail. System activity, so we're looking at things like error reporting per host, for example. Is there a system that's got a spike in errors? And service failures as well. So if a particular, if bind doesn't restart, for example, then we wanted to be aware of that. So these are the sorts of dashboard items that we have. So for our web-facing systems, we want to know the non-200 status code. We want to know when there's a server error, for example. For our network resolver service, we've got things like RPZ, and taking that data allows us to then notify people when they've got infections on the Janet network that they might not know about otherwise. Breaking down silos is something that we saw on the last presentation, and hopefully some of those are kind of similar and quite overlap on this one. So we go about demonstrating and kind of advocating the tools that we have and how they can benefit teams. We understand the other kind of visibility gaps that those teams have and how we might be able to help. We want to understand their skill sets as well. Is there something that we can help with that they don't have? But I think that works both ways as well. So with our cloud team, for example, we don't necessarily in the security division have much experience with AWS, but they do. So we know that there's an existing knowledge base that we can go to if we need help. It's about understanding their challenges as well, and in the sense of, is perhaps security one of millions of things that they do on a daily basis? Can we take that away from them? Is there something that they want to do with data, but they're not quite sure how, and whether we can help that? And ultimately, it reduces the duplication of effort as well. If you've got 5 or 6 different technical departments all running similar systems, then it makes it much more efficient to kind of club together and work together as a group on this one. And I find also that understanding people's technology stacks helps as well. So just doing a bit of research about what they're using, whether it's AWS or Azure or kind of more on-prem systems, if you start to learn their language, I find that they're a lot more willing to come and talk to you about and start engaging with you about these things. So just very quickly, because I appreciate I'm running out of time, on the Jisc Splunk partnership goals. So we wanted to help organizations improve their visibility. We wanted to make log data analysis and SIEM solutions affordable. We wanted to provide something that we knew that was mature and well supported. And we wanted something that we knew that covered a multiple use cases, whether that's security, IT ops, whether you're doing business analytics or student analytics. We know that Splunk can cover these things. And like I said, we already have a community of knowledge, and so we want to build on that as well. So we've got a few challenges. The common complaint that we had was, I want to use this, but it's really expensive. So we worked really hard with Splunk since kind of summer last year, really, around how we can negotiate decent pricing for you all. It's complex, is another thing that we hear. What we've worked with Splunk on is how do we bundle professional services in with licensing so that we know that you're going to get decent support from the start, you know that you're going to get up and running very, very quickly, and make it much more valuable to your organization. We've also negotiated some free training as well, so for the users of the system, they can get up to scratch quicker. It doesn't take your analysts or your security staff or your IT team months to get on board with it. They need to show value to the business quickly. So by providing things like pre-built dashboards and reports as part of the professional services, that allows you to get up and running much quicker than having to try and build them yourselves. You don't want to become shelfware, and that's a common thing that we get. We bought this, but it doesn't really do what we want it to, or it doesn't get adopted by the various different teams. So we wanted to focus on kind of how do we make sure there's continuous development and improvement. So Splunk already had a bunch of user groups that people attended, but now we're looking to expand that. How do we get more people to come along? How do we get people to share their knowledge of how they use it? Can they share use cases? Can they share searches? And just make it much more easier and more efficient for people to use. And then the last point is people say, oh yeah, that sounds really good, and we want a Seems-like solution, but we don't want to manage it. We don't want to necessarily deal with the kind of initial alerting. We want someone else to do that and just tell us what we need to fix. So we're actually building a managed service right now, and we're in the process of piloting that. So if you're interested in getting involved, then please let us know. Or if you want any more information, you can go to the webpage there or contact security services at jisc.ac.uk. Okay, that's me. I can happily take questions, or I'll be around for lunch if you have any.
Just while Jim's doing that, actually, Mark, I'm quite interested just to see how many people here are actually using Splunk. Show of hands. So, of the 20 that you mentioned within the sector, we've got a fair few here. So, yeah, please, if anybody's got interest, talk to Mark or talk to each other.
Yeah, exactly that.
Any further questions? Nope.
Cool.
Thank you very much.
Everyone.